In this video, I'm going to go over how we classify chemical reactions. These are the 5 different types we're going to look at: combination, decomposition, single replacement, double replacement, and combustion. Let's check out the first one here. Here we have a piece of charcoal sitting on looks like a burner, and this is what we picture it to look like. Here are carbon atoms all linked together, and here's our little equation for it. So we have carbon reacting with oxygen and forming CO2. Now, if you notice, our equation is all balanced. This is an example of a combination reaction, which in many books is called synthesis. If you notice, we have 2 reactants and only 1 product, and that's why we have A plus B yields AB. So that's just a general equation. Now for this one, it's 2 elements combining to form a compound, our elements being carbon and oxygen. But it's also common to have 2 small compounds combining to form a larger one. So you want to be able to recognize this type of reaction because you only have 1 product, but you have more than 1 reactant. The next type we're going to look at is a decomposition reaction. And here we have a battery sitting in a glass of water, and that 9-volt battery is actually decomposing the water. And we can see here in the diagram how we have a lot more gas coming from this electrode than this one, and this is the hydrogen gas. And you notice that it's a 2-to-1 ratio in our equation. So here we have just 1 reactant, which is a compound, the water, and it's forming 2 products, which are the elements. So this is the opposite of synthesis. Now the next reaction we're going to look at is called single replacement, where 1 element replaces another element in a compound. Now here we have Y reacting with A and B, yielding A plus YB. So you see how Y has replaced A. Now in this case, because A is the first element written in the formula, A would refer to a metal. So that means that Y must also be a metal in order to replace it. So a metal can replace a metal, or a non-metal can replace a non-metal. But you don't have a metal replacing a non-metal. So let's see the example. So this was a piece of potassium added to water, and it's violently reacting with the water. So potassium is the metal, and in this case we're looking at hydrogen as being a metal. So the potassium is able to replace one of the hydrogen atoms that's in water. Now when they combine together, we get this gas produced, hydrogen gas, which is flammable. That's why we see the flame over here in the beaker. So a single replacement reaction is when you have 1 element reacting with a compound, and you get another element in a compound produced. So you have 1 element replacing the other in the compound. Now the 4th type of reaction we're going to look at is called a double replacement. Now here we have 2 compounds reacting. Put my arrow here. Now compounds, in order to react, we have to first somehow break the bond that binds them together. We're not showing this in the overall equation, but if you notice, A is bonded to B over here, and now A is bonded to Z. So in a sense, A has combined with Z and Y has combined with B. You notice also on this side that Y was written first again as it was over here. A was written first again as it was in the beginning as well. So this is a very common kind of reaction. And here's my example. So I'm adding 2 solutions together. One solution contains sodium chromate, and that's actually coming from this graduated cylinder. It's a yellow solution. And in the beaker, I have some lead nitrate solution, which is really clear. And the instant you put them together, you get this yellow-looking solid that's formed, and that's my product. And I can figure out what the products are by just switching those names. And here they are here. So my products are sodium nitrate and lead chromate. Now you don't have to worry about figuring out the products at all. You just want to be able to recognize that type of reaction. So in this case, my solid, you can see by my equation, is lead chromate, and that's actually called a precipitate. So this is an example of a precipitate reaction. And my last type of reaction I'm going to look at is called combustion. And in combustion, we are burning some things, so it's going to be a reaction where we're combining something with oxygen. So in this case, we're talking about the gas that we use to burn in a Bunsen burner. This is methane gas, and that's the formula for methane, CH4. and we're combining with oxygen, and we make carbon dioxide and water. So anytime we take a hydrocarbon, which is methane, hydrocarbon means just carbon and hydrogen in the compound, and we react it with oxygen, we're burning it, and we always make carbon dioxide and water if we burn it completely. So you just have to look and see, am I reacting this hydrocarbon with oxygen, and that's going to be then a combustion reaction. So here are 5 of them for you to look at, and just by looking at the reactions, can you tell what type they are? So why don't you pause the video for a second, try that, and then come back and start it up again. You'll see the answers. Okay, and here are the answers. So the first one is a combination reaction. You can see we have 2 elements forming a compound. And the second one is also a combination reaction, 2 elements forming a compound. Now, the third one looks like just the opposite. We have 1 reactant breaking down into 2 products. That's going to be decomposition. And here we have, oops, this one is done wrong. It says iron plus oxygen. This wouldn't be single replacement. This would actually be combination again. So I got to cross that one out. So, get my pen here. So that's really, get rid of that. And that's really going to be this one here. So we'll bring it right down there. Here we go. And then for the last one, we have iron oxide reacting with carbon. And you notice the carbon has replaced the iron. And so the carbon is now forming carbon monoxide. So that's a single replacement reaction. And that's going to be it for this video.